Well, the models I've built to date have been either Godley Table models or Flowchart models. Of course, the whole idea of building Minsky was to enable the two to be combined, so we can do monetary modelling as well as physical modelling in economics and in any other discipline where that assists. So I'm going to build my model of Minsky again, starting from scratch, and also wherever it's important to talk about financial transactions between parties, I'll use a Godley table for that, rather than just a set of equations on the flowchart. So I'll just actually title this banking sector, and I'm going to have, just open up the table, and we're going to, of course, there's going to be debt. So it's going to use simply the word debt for that. I'm not going to have any other assets yet, so I'll leave the other assets free. I'm going to have firms that are borrowing money, workers that are being hired by firms to produce output, and then the banks whose equity is essential to them to be able to make loans in the first place. So let's say debt starts at 100 and there's 90 in the firm's accounts, 5 in the workers, and the bankers of course necessarily have to have positive equity. So there's our initial starting conditions, and that also defines the primary bank accounts in the system. I'll just make this, put this in editor mode, so as I add the other details to the model, then we can add additional rows here and see it on the canvas rather than having to go over to the Godley tab and see it over here instead. So starting from that point, let's just start from the same basic idea as I did in the previous model where I built the Goodwin model and then Minsky model on top of it. I'm going to start from net investment. So I_N for net investment here, and that's the flow which we'll have to define as we go through the rest of the model. But the basic idea is that net investment integrated becomes the capital stock. So we next need a capital stock variable here. I'm going to rename that to K. And then in net investment integrated is capital stock. We need an initial level of capital stock. So I'm going cheating to check another model here to see what I did in the past. I made a couple of stuff ups as I chose arbitrary numbers in previous simulations, so I'll try to avoid that hassle here. By the way, notice the square cursor, that's for grabbing things and moving them around. Sometimes Minsky doesn't reset, just press the shift key and we'll go back to the right one. And now I have K_0 for the initial level of capital, and I give that a value of 200, and that's a parameter. I won't bother with the range. You can see the default ranges are huge in Minsky. Maybe just to stop that interfering with the simulations, if I press a key accidentally at the wrong time, then I'll just start this off with 1000 to 100 and a step size of 10. And then drag and link that up to the capital stock. Let's just zoom in a bit while I do this. So there's your initial investment. Then you get capital stock. Multiply this by the efficiency with which machinery turns energy into useful work, and I'll get a value of 0.33, which is the inverse of 3, which is the usual value that I provide for the accelerator relationship between capital and output. And get a maximum value of 0.45, minimum of 0.1, not quite that low. And a step size of 1%. Okay, so multiply, and I'll put to, I'll leave it there. Multiply that by capital stock by the efficiency of conversion of energy into useful work. That's what then gives us our output, which I'll just use the symbol Y for. And now we go through the rest of the proceedings. I made it slightly more complicated in the last model because I included my labour into the model by having a capital to labour ratio, which I think is more realistic, rather than an output to labour ratio. But for simplicity here, I'll go for an output to labour ratio here, and that's a variable growing over time, so I need a differential block for it. Edit this, call this A, and then right click, take a copy of A, multiply that by alpha, which is the rate of growth of labour, the output to labour ratio. I'll just actually edit this now that I've got a separate instance and call it the output to labour ratio. And then multiply that by alpha, which is the parameter for the rate of growth of technology effectively. Given a maximum value, say of 4%, minimum 0, step size 0.001. So those two multiplied together is going to give us the level of technology, but I've got to have an initial level as well. And for the, we're just going to use A0 for that, A underscore 0. Hang on, I typed that potentially on the, I didn't say, so let's try again. Hang on, what's going on? Shift key, okay. A underscore 0. Parameter, initial value just of 1. I'll give myself a bit of a range to play with, just in case I need to. So there's A0, that feeds into your initial condition. So we've now defined labour productivity, and so then we now can take a copy of A from here and then divide labour by, divide GDP by that, and that's going to tell us how many workers are hired. So we're getting close to the stage where we need a Godley table here. So that now gives us L, which is the number of workers employed. And now I want to divide that by population, which again is going to be a variable that grows over time. So call this N for the number of people. Oh, whoops, let's just edit that. I'm going to rename all instances rather than run any dangers of that stuffing up things later. That's got rid of anything inside the code of Minsky that still had N there. Same basic idea. I take a copy of N. Now I'm going to multiply it by beta for the rate of growth of population. Let's say it's quite a high rate, give it 3%, maximum 4%, minimum 0, step size 1%. So now I have beta n multiplied together, integrated is the value of n, and I need n0, and I'm going to use, and this is why I was checking my numbers earlier, to see what I started with. Let's just go back and take a look, 110. Okay, so n, now, I've got to click on the canvas, I think that was what was going on, n underscore 0. That's a parameter, and I'm giving that a value of 110. So now, copy of n, divide L by that. We have the employment rate, which I use lambda for. And now we're getting to the point where the Godley table is going to start becoming relevant. Just checking my other model as I build this so I don't make any big stuff up. So I want to finish this one rather than having to come back and do it again. It's happened a couple of times. Okay. Okay. So now let's just calculate this as it stands. I have initial capital here, so I'm going to get an output, and I've got labour. The employment rate comes out at 66%, which is roughly where I wanted to start with. Yeah, I'll leave it at that level. Okay, so now I want to, again, notice that square cursor effect. Take a copy of lambda, and now I'm going to have z, lambda as before, z underscore backslash lambda, and I've misspelt that. Let's go and fix it up before we give it to Minsky to interpret. Lambda as a parameter, value of 0.6. So subtract Z lambda from lambda, you work out whether the employment rate's above or below the level where wages are affected. Then multiply it by a slope. I'm going to have S underscore lambda. Give that a value of 10. And just to be slightly more explicit, you multiply the two together, that is giving you the rate of change of wages. So I can actually express that. I just have a variable, say dw slash dt, and that's now the rate of change of wages. And then if I multiply that by the current level of wages, which we now have to bring in as another integral block, so I can type the ampersand and do that very quickly, bring it up on screen, call this W for the money wage, and then we have dw dt, which comes out of the work down below, this bit, copy of W. So those two multiplied together and integrated are equal to the current wage, and we need W0, and I set that at 0.7. So now I need a W0. Again, that's square cursor effect. W underscore 0, parameter 0.7 for initial value. Okay, so now we're getting to the point where I'm actually going to bring in wages, because we now have labour times the wage rate multiplied together is total wage bill, and I'll just use W, capital W for that. So it's capital W. Now I get to the point where I can actually start using the Godley table we defined up above. So I'll just call that W there, and then go to the Godley table and bring up the Godley table. Pardon me, that's a bug in the old version. You won't see that when you use the new version. So pay wages. So wages are going to be a flow of minus W from here to W for workers. And that, of course, we now do have consumption by workers. That was implicit in my original Minsky model, but I'm going to make it explicit here. So that's me consumption coming out of the firm's account and goes into comes out of the workers account, goes into the firm's account. Now I now have to define CW on the canvas. So let's just make the canvas a bit smaller so I can actually show the browser window as well. Amazing how fast you can get parameters and variables turning up here. So now I've got CW, and the easy way to define CW, which I'll change later, is to say that workers just consume all their wages. That's the standard assumption made by Koleski. So for the heck of it, I'm going to just use that here. If I hit my reset key over here, then you'll see the flows into the bankers' workers' accounts are the same with the flows out, so they won't accumulate any money. The later one I'm going to do is change this so that there's a time delay in workers' consumption, and that's controlled through the Godley table. But that's simplified it fairly effectively here. Now we have wages, subtract wages from output, and you're going to get gross profit. So I'll just indicate that as pi underscore g. So backslash pi underscore g for gross. That's gross profits. And then now we have the firm is going to, should I use gross profits or do I just, yeah, use gross profits, okay. So now of course the firm's going to be paying interest. So go back to the Godley table here, and we have debt. I haven't included, in fact, in there that pay interest on the debt. So that's going to be necessary. So that's going to be minus INT out of here, INT going over to the bankers, and again the same basic idea is that I want spending by banks, so I'm going to have minus C underscore B for consumption by banks. That goes of course to the firm sector. And now again, for simplicity, I've now got interest to find, so I bring interest, and these are all in alphabetical order here, so just look from that way. There's interest, and that is equal to the rate of interest, so I'm going to call this R underscore D for debt. One of the hassle, debt and deposits using the same character is a bit of a pain. Make this a parameter, say 5%, maximum 20. So RD, and I've now got debt there, of course, so I've got to bring debt down. And those are interest payments, and now if I subtract interest from gross profits, I get net profits. So backslash capital PI underscore N for net. Now there's net profits, and now we have investment, the desire to invest. And that's going to depend on the rate of profit. So I was quickly just going to now define the rate of profit. So take a copy of, that's where it's K over here. Divide net profit by the capital stock, and you have the rate of profit. And now I want an investment function, similar to what I did with wages a moment ago and what I've done beforehand. So I'm now going to have, I'm just going to check and make sure I don't give myself a need to redefine the damn thing if I make an error. So just give me a second to check that. I do. Okay, so I'm going to use my Z, my 0 point for, again, that square bracket. Just press the Shift key once you're actually on the canvas. So Z underscore backslash PI superscript R. Parameter, give that a value of 3%, so at 3% firms don't invest anything. And above that they do, and at a certain level they start to invest by borrowing money. So we have actual profit rate versus this target profit rate. Subtract the two, you've got the gap between the actual profit rate and the level at which capitalists don't invest any money. You then multiply that by a slope of the investment function. Another parameter, give that a value of 10. Multiply those two together, whoops. And now you have gross investment as a percentage of GDP. And multiply that by GDP. Hang on a second, let's see what I did here. Okay, we had a version where grouping was done. I haven't shown grouping yet because there are a couple of hassles in grouping. We're fixing them up with the next beta release. So just to avoid those hassles, I'm not using them here, but it's quite possible to use grouping to hide some of the complexity here, but still have them available for later use. So there's gross investment now. So why are those two up? So now we've got something from which we can then have borrowing turning up. So we have gross investment and net profit, which are here. So I'll just now take, again, that cursor. Okay, take a copy of gross investment, and investment minus gross investment and net profits can be deducted together, because gross investment is talking about what you actually borrow money to do, to build, and then you have depreciation, meaning you've got replacement costs as well. So it's gross investment I subtract here rather than net investment. So now minus gross investment, and what you have now is the rate of change of debt, but we have debt in the equation up here. So what I want to have now is credit. So I'm going to type credit as a variable, and that can be positive or negative. If investment is greater than profits, then credit is going to be positive. If it's less, it's going to be negative. We now go back to the Godley table, which is here, and I now want to show credit. And that is going to be credit dollars that turns up here as the finance, but it also of course turns up as debt here. So now we have the stock flow consistent treatment of the Minsky model I built way back in the early 90s, but going through the Godley table to show the stock flow consistency. At the moment, let's just hit the recalculate key and see what happens. Okay, there's going to be positive borrowing coming out of that. So now we have credit, we have gross investment, and I now need to define net investment. So take a copy of gross investment, whack it down here. Let's just change the scale a bit. So that minus depreciation is going to give us total net investments. We're going to go that multiplied by delta underscore K. I'll give a value for that of 6%. So that multiplied by that is depreciation. We now type a minus key, and then wire up gross investment minus depreciation is net investment, and I think that's, strangely enough, I think that's the whole, what's over here, let's see, what have I got here? Pi n, so I just must have accidentally defined that once before. Just going to hit the run key. And I've got negative amounts turning up there, so I've got to do something more to see what I got wrong in the previous model, which gives me fine values. Hit the recalculate key. Consumption by banks, which I haven't included. Okay, so what I have to have there, the simplest way to do it is to say that consumption by banks is equal to the interest payments. So bring that down here and wire that up like so. And now when I simulate, okay, stop it and go forward. I'm still getting negative debt there and the system is freezing. So I'm doing something wrong. Let me just check and see the other model that I got right before I did this one. Always stuff up when you do a live demo. Okay, let's go back and show what I actually wanted to build, because again, these things, it's easy to make a mistake as you start building a model. So let's just run this one to show that I actually got it right. We have rising debt, rising amount of money in firms' accounts. And what I've done differently to the model that I've built up here so far is that I've got a delay between consumption by workers and wages for workers' consumption using what's called a first order time lag. So that, I can find, but that is actually shown here. So rather than having workers spending their wages, so I could have wages here going to consumption, I've got the amount in the bank balance
divided by a parameter which is called the time constant, that tells you how long workers could survive effectively without getting any income. And that is a tiny number, which indicates they could survive 0.4 of a year, which is about 2 weeks, whereas we've got capitalists being able to save bankers being able to survive 1.5 years. So a bigger effective buffer builds up in the bank's account, even though they're a smaller component of the spending in the economy. So that's what I wanted to get to, and I'm just going to go back and see what the F did I do wrong to not get the outcome that I've got shown up here. You can see I've got more elements in the model, so I may not have actually defined extra elements that I needed to define. So just looking over the overall model. You see what I did wrong to get that different result there. I'm not really sure. This is the sort of thing I need to sit down and work it out properly. So I might leave it at that and show that the models can be combined, and I'll put the finished one that I did up on my Patreon page as well. But the basic idea is this is just the beginning of integrating a physical model with a monetary model. And of course I'm also leaving out price dynamics here. Effectively I'm assuming that price is a constant. It's fairly easy to add price dynamics inside here using a Koleskian pricing equation, and then your monetary transfers have different numbers, of course, to the physical values of the economy. You have inflation, deflation, and so on turning up. And of course, this is a toy model. You get far more sophisticated models being made by some of the people who are using Minsky seriously now. So this biggest model we have is probably the one of the Portuguese economy. Second biggest would be Ty Keynes's model of the pandemic model. They're using a Godley Table to create a model of epidemiology. But so the basic story is it's extremely easy to integrate the two. You've got to obviously take more time than I was able to check my values as I type this thing in live, but you fundamentally get the dynamics of a capitalist economy coming out of this, including the monetary sector, which of course neoclassicals omit. I'll leave it at that, and I might maybe do a supplementary model where I check and see where I made a mistake to get the trends being negative in borrowing there rather than positive for the entire system. Well, one of the things that Minsky has uniquely is the capacity to see your equations as you build the model, and I wasn't able to spot the problem easily looking on the flowchart, but it was obvious when I looked at the equation, because my definition for the rate of change of wages, which is, if I can find where that is here, I had rate of change of wages is the slope of the function multiplied by. It should be the slope multiplied by lambda minus yz. So what happened was, in putting the model together and talking at the same time, I didn't realise I'd typed the divide by key there rather than a minus key. So I had to delete that. Now wire this up to here and then hit the run key, and then we get rather different dynamics. So this is showing the fact that the dynamics of this model are pretty much the same as the one of the completed model that I was working to beforehand, except for that little mistake. Again, it's very useful to have this capacity to go and check and see, well, what have I written in terms of equations versus what I've done here. And we hope to at some point add the capacity to actually see expressions like this as an equation on screen rather than the flowchart, because sometimes it is hard to read a flowchart and realise what you've actually done. So the final thing I'm going to do is just run the model for a few cycles and show that the Koleskian assumption that workers spend all their wages matched with bankers doing the same thing means that there's no activity over here, and you can't include any financial dynamics for the workers or the banks in the model. So what I do instead is, let's just delete that wire and delete that wire, and now define consumption by workers and consumption by bankers as a function of the amount of money in their bank accounts. So I'm just going to go across to the browser again and bring over workers, which is the bank account for workers, and banks, which is the bank account for the banks out of which they can spend, and say that each of them have time lags. the time, genuinely time lags rather than time delays as most economists use, which are reflecting the length of time they could survive without having to get any more income into their account. So the time constant for bankers is going to be a large number because we expect they can survive, you know, say 2 years with no extra cash coming in. 5 years, the maximum, so step size of 1/10 of a year. So now I then divide the banker's account by tau B, and what I'm going to get is their consumption level will be substantially less than 5. Hit the recalculate key and I can see what that is. Okay. The workers have much smaller bank balances. There's many more of them, but they take longer to, well, they've got to spend more because they're poorer. So I now have tau underscore workers, and argue that they might be able to survive maybe a couple of so 2 fortnights, which is 0.04 of a year, roughly 0.05 or 1/10 of a year, maximum say a 1/20th of a year, maximum 1/10 of a year, minimum a few days, step size of 0.01, and now their consumption will be much larger than the amount of money in their bank account. So they've got, you know, bankers and workers, as I put them here, have got the same amount of money in their accounts when the model starts, but the consumption by workers is going to be much higher than the consumption by bankers, so 100 versus 2.5. And this is one reason that money does not trickle down, it trickles up. If you want to put more money into the system, you put it in the hands of workers. Just run the model and you now see that the amount in the workers' accounts and the bankers' accounts changes over time, changes dynamically, which you didn't get beforehand. And if you wanted to now extend the model and say, well, let's take a look at government spending, for example, then what I'd need to do is create a new asset called reserves. And now what I have is, let's say, government spending. And let's just say that all goes, I'll just call it G underscore S for government spending. Let's say that all goes on workers. And then I could have taxation as well. And let's say that came out of the firm's accounts only. And now you're starting to get a more integrated model, and I can include a response reaction by the government to the level of unemployment and so on, and have that affecting the dynamics of the model. And I could show the other activities of other sectors by expanding the tables to give you an idea of just how large they can get. And I know this, what I'm seeing here is a rather messy model. Well, you see Pedro Pratas's for Portugal, which Pedro is going to be, I hope, dramatically revising when he puts his PhD in at some time in the near future. And this is a model which has been derived entirely from national accounts of Portugal, and it's more accurate than the model used by the central bank or by the Reserve Bank of Portugal. But you've got an enormous model there. You can see he's still using, still has the variables turning up on the outside of the Godley tables, which we no longer require, and all the various bits and pieces of spiderweb, which is what we have rather than spaghetti code, scattered all over the canvas. The better way to go is to build models like the ones that Tyrone Keynes builds, where they're just superb attention to the layout of a model. So let's look at one of Ty's models here, and I'll go for the pandemic model. And make that full screen. And though it's an incredibly complicated model, it's quite much easier to follow the layout because you've got the capacity to zoom in and see how different elements are defined, or using a standard layout, well documented and so on. But that's the sort of thing you need to do if you're going to make a model you intend showing to other people and saying, let's see if we can actually run an economy or modelling a pandemic in silicon before we try doing it in the real world.